Hi, okay, my name is Mark. I'm based in London, Kent. Yesterday I posted a small introductory to Gambas 3. First of all, let me say to you all, welcome to Lesson 1. In Lesson 1 we're going to cover where you can get that information from, all about Gambas 3. So if we look there and we look at the website, just have a quick look, pull that up. You might want to pause the video at this moment in time just to take note of the address. It's https://gambas wiki.org/wiki/docs/start, and on the left hand side you will see a lot of information that you could start going through on your own accord to gain a better idea of what Gambas does and how it actually works. So, having that being said, we also need to know how to install it. So we're going to use a package manager which is shipped with most Linux distributions, called Synaptic. And the way that you do that is you go to your application launcher, come up to the top there and do a search on Synaptic, SYN, Synaptic Package Manager. Launch the Package Manager. It'll ask you for your admin password. And then if you look at the top right hand corner, once it's loaded, you'll see a search button. Click the search button and inside here type Gambas, Gambas 3. And there we go. The package that you're interested in is Gambas 3 itself. It is a complete visual development environment for Gambas. You shouldn't have to mark any of the others, but for your own sake I'd put, if it's not clicked or ticked or selected, click Gambas 3 development and Gambas 3 arguments, and hopefully the rest should automatically install. There will be a couple of packages that are missing and you might have to go back in and select those later, and all you do is click apply, having selected those packages, and that will install. Wait for the installation to finish and then close the window down there by using the X on the top right hand corner. Failing that, you can also install from the terminal, and on Linux, to pull up the terminal, all Linux distributions, to the best of my knowledge, unless they've changed the hotkeys, should be launched by holding the Control key, the Alt key and the T key down simultaneously. That will then launch the terminal for you. And here what we do is we do a sudo apt update and double ampersand sudo apt upgrade, and then click enter. It will prompt you for your password again, your admin password. And then it will go through the package manager and it will select whatever is required. Hopefully that's all done, and having done that, you then click sudo apt. You did type in on the same line, sudo apt install Gambas 3. Click that, and it should then, if it finds the package, which it should do, it should then install it, and it will tell you that, at the bottom, that there's 0 to be removed, 0 to be installed, and 0 to be upgraded. Having done that, just click the type in clear. That will clear the screen, so that you've got a nice clear screen to work with in terminal. And then what I want you to do is to make yourself a project directory, and to do this you use the command mkdir, and the project directory what I'm going to call mine, or name mine, is Gambas projects. And click enter at the end of it, and then to check to see if it has been created successfully, just do an ls on Linux systems, and if you look through the actual list you will see Gambas projects there. It's all done in alphabetical order, and that's that for that stage. So it's quite simple, hopefully, no problems. And now what we're going to do is we're going to look at the IDE itself. An IDE stands for Integrated Development It's a tool that we use for writing coding and creating GUI. It has a graphical user interface so that you can drop buttons onto a form or a template, if you like, to which you can attach code. So to launch Gambas 3, you go to your application launcher again, click there, and inside the search bar type GA, and it should come back with Gambas 3. Launch the IDE. Excuse the noise in the background, that's my fan working overtime. That's because it's a very old computer, but it's doing marvellously well. There are tips that are shown from startup. You can actually iterate through those tips if you like. It gives you a little bit about strings. It'll give you all sorts of tips that you can actually go through. My advice is don't untick that. Leave that as standard, because if there is an upgrade or an update, then there'll probably be more tips added, in which case they'll be worth reading and having a good look at. Right, so to start a new project in Gambas, we've got represented with new project, open project, recent projects. We're not really interested in any of these at the moment, apart from maybe quit. We select new projects, and we're going to do a command line application because that's the simplest of all to start with. And then we can get a fair idea of what subroutines are and functions are, and I can also talk to you about why Gambas is an easy language to learn insofar as it's applicable to writing algorithms as well. So click command line application, click next, select your project folder. Mine happens to be Gambas projects, there we go. Click next, and I'm going to call our first project we're going to start with is a very simple one, and it's simply add two numbers. Right, for the project title, I'm going to use a very simple project title, add two, and then click OK after that. Now we'll be presented with the main IDE. This is the main IDE up the top here. You've got your normal menu functions: file, new project, open projects, so self-explanatory. Project, compile all. So if you've got a large selection of code belonging to different projects, it will compile all the code for you. Debug is exactly what it says. If you are hitting problems and you can't, say for example you put in a value, you've done something with a particular value, and the answer doesn't seem correct, then debug will be your tool to actually find the problem. You can also, as a matter of interest, Gambas will automatically debug should you put something incorrectly or declare something incorrectly. It will find that straight away as soon as you try to run it, and it will stop at that line. Tools, I'm not going to worry about that too much. View project is exactly what it says. If you untick that, you won't see the project folder. If you tick project, you will see the project folder appear. And then we've got the normal buttons on the actual application, which is run, pause. You can step into the project code itself. Forward, if you're going to use a function, you might want to jump out of the function or jump out of the function. Yep. And then run entire until current line. So you can put a stop on a line and run it until that line. So in the project view, you can see our project title that we selected. It was add two numbers, and under sources you will see main. Click main, and every application has what they call a main function, a main entry point, if you like. It doesn't matter if it's Java, it doesn't matter if it's C or C++, they all have a main. Even Qt has a main entry point, and it's called main. Because what the application does when you launch it is it looks for this main and starts executing code from there. So it gives you a very basic line of code, which is print hello world. And if we go down to the bottom of the console, now the actual IDE, you'll see console marked. Click that button there, and there is Gambas IDE's own built-in console. If we then click run, it will do exactly what it says. It will print hello world. So we don't really want that. We are going to be creating a program from scratch called add two numbers. I'm going to delete that there, and I'm going to go back and have a look at something called flowcharts quickly. So I'm going to leave that open. Right, there we go, and we're going to start writing our main program. Right, so when we begin programming, the first thing that we'll always do is we'll write something called a main method, and this is where Gambas shines, because whilst you're writing code, which is near enough plain English, as I said, it's as basic as it gets. It then teaches you to do something called flowcharting, or you will learn to write flowcharts for code. And so the first step is going to be to ask a user to input a number. But before we do that, obviously we've got to tell the application where to put that number. So if I come back to my IDE, we have to use something called a dim statement. And what the dim statement stands for, dim means dimension. We have to tell the computer how much memory to actually set aside for the different storage containers, or different storage variables you like, that we're going to input data into, or place data into. So we need a storage or a variable to hold our first input that we've requested from the user. So I'm going to call that num1, and we're going to define that as an integer, because an integer is a storage within memory, or it defines storage in memory as being able to hold a value between, a numerical value between -2147483648 and +2147483647. So you can see that by telling it that, if you exceed that number, then it's going to overflow, and there's what we call buffer overflow. So I'm going to keep buffer in the back of your memory at the moment, because buffer is quite important. And at the same time, we also want to comment the code. So to comment the code, we use an apostrophe, and we basically, to remind us what we're doing, set aside a variable in which to store a number input by user. Now the reason why we comment code is that when it comes to debugging code, if we don't put those notes in, and somebody else happens to be debugging it or trying to find a problem, they don't quite know what you've done. So this is the main reason why you debug code, not just to remind yourself, but also for other people's purposes if they need to go in and debug that code. So comments are very important in coding. So we're going to do that. Let's go back to our flowchart quickly. So we ask the user to input a number. And the way that we do that, so I've got flushed the buffer there for a minute. How do we ask the user for a number? Well, we use the print statement. Print. Oops, sorry, beg your pardon. Please enter first number. Whole number. Okay, I'll put a colon there, and at the end of this I'm going to append an apostrophe, semicolon. And the reason why I say semicolon there is because I want the cursor to appear directly on the same line as the print statement, or the text that I've sent to the console, which is this here. I'll just delete that for a minute. Otherwise, it's going to appear below the actual print statement. So if I were to say print first whole number, if I just run that very quickly, you can see it says print whole number. And there you can see the cursor directly on that line. It just makes it more user friendly. So by placing a semicolon outside the text, which is contained within inverted commas. Text, by the way, is a string of characters. It's also a collection of characters, if you like, or what you could term a character array. Alright, we'll talk about arrays later on. But for the moment, accept that that is a string of characters. Okay, so we've done that. Now, remember I said something about buffer. Every computer, when we use the print statement, what it does is it takes this text here, first of all, and it puts it into what they call a buffer. The print statement then iterates through that text within the buffer, which is stored as characters, if you like, and it sends it to what we call the console, or the standard I/O. Okay, the standard input and output. The standard input and output comprises a keyboard in which you enter data into, and the output, which is obviously your screen. So that's what standard I/O implies, or console, if you like. So before we can actually accept data back from the actual keyboard, we need to flush the buffer. So flush is the next command. Alright, so we go back to my algorithm again. We can see that we've flushed the buffer, and now we need to read from a standard I/O. But to read from a standard I/O, we also need to place that data into something. So when we read the standard I/O, it accepts the keyboard has its own internal buffer, and what that does is it places anything that you press on the keyboard inside that buffer, and when you press the enter key, it sends that buffer via a USB port or via a serial port to the computer, whose hardware then reinterprets that, and it needs to place that somewhere. Now, bear in mind, I also said that this is what you term a string. It's a string of characters. So I need to place another variable in here, dimension, and I'm going to call that str answer, and we have to declare that as a type string. Alright, so that's where it's going to place that data. Okay, so there we go, all done. So now don't forget to comment, set aside a variable to store data from the keyboard. Whoops. To store the keyboard, what do we call that? Store the characters entered via the keyboard. Right. Okay, brilliant. All done. So to do that, we need to use a command called line input. Line input is how you actually read data back from the keyboard in Gambas. So line input, and we need to pass it that function there, string answer. So if I copy that, notice how it autocorrects as well the commands. So it's going to place what we enter in there into the keyboard. The trouble is that it's a string, and it's ASCII characters, UTF-8 characters, and we can't deal with a string. If I were to put A in front of you, A has got a numerical value. On a keyboard, every letter has what they call a numerical value. So if I were to push 1 on the keyboard, it wouldn't have a numerical value of 1. And if you look up the ASCII table, which you can do online, you'll find out what those keys represent in terms of numbers. So we have to convert that to what we call a numerical value that we can understand. So there's a few types of numerical value. One is an integer, one is a float, one is a long, one is a short, and then there's byte, and there's a few others that are contained in those notes. So it's worth reading. I've used float in this case. We've assigned it to a string, so we've read from the standard I/O, we've covered that, we've assigned it to a string, Now we need to convert it back to a numerical or human readable value that we understand as a number. So I've used float here, CFloat. In this case, I'm going to use CInt. CInt is a function that will convert that text representation stored in answer, which we've typed in from the keyboard, and it will convert it back to an integer, right? So I've got to store it somewhere, so I'm going to take num1 equals CInt, right? And the CInt expression is variant, and it returns an integer, and the value that we want you to pass into that is obviously string answer, str answer, right? Now you can see it's got a star there. Now it looks like a star and it's a pointer, alright, to string answer, because when you want to talk about a string, really and truthfully, it's what they call a character array. An array is a pointer. So keep that in mind as well. It's a lot to take in to start with. If you've never done this before, it is a lot. Alright, so we've done that. Brilliant. So the next thing we need to do is we need to repeat that whole process. So let's have a look at our algorithm again. Ask the user for the next number. Alright. Flush the buffer, because we can't read input back from the keyboard, or we can read input back from the keyboard, but we won't see the print statement for the ask user for the next number, and this is why we flush the buffer inside the computer, and then we're going to need to read from standard I/O. So let's do that. So we come back to our there, and we want basically that set there all over again. Copy that. Okay, paste that there, and please enter second whole number. Is what's going to change. Second whole number, and we also want that changed to num2. Right, so let's just make sure we got there. Now we haven't got num2 as a storage container yet, so we have to add another variable. So it's dim num2 as integer. Okay, so done that, right? So now we've got num1 stored, we've got num2 stored, and finally we want to add those two numbers together. So if I go back to my algorithm again, we've converted it, assigned to a string, converted it to an integer. In this case I've used float because I wanted to do something else later on, and we now need to add both numbers, right? So, alright, we need to add both numbers, so we're going to have a result after adding numbers, okay? We've got to put that somewhere, so we have to store that in another variable. So if I come back to my code, the next storage container or variable that I need to declare is an answer of some type. The answer as an integer, because we're adding two integers. We can only store integers in integer type memories, integer, and strings in string type memories, and so that is how the computer deals with data. So you can't put an integer, for example, into a string, and you can't put a string, for example, into a container that holds an integer, and there's a number of reasons which you'll find out later. So having got that far, we need to add the two numbers, and we need to put that into answer. So answer equals num1 plus num2. Yep. So we're going to add those answers. Right, so add num1 to num2. Alright, having done that, we now need our final steps, which is, let's go back to the algorithm, and the algorithm is store this result in answer, so it follows the code directly. You can see how it's following the code, yeah. And then obviously print this result to standard I/O, standard I/O being your console or your screen. Right, so we come back to the code, and it's print the result of adding both numbers And here what I'm going to use is I'm going to use a semicolon, as a semicolon is a way of appending data. Now you can append data to a string. In other words, you can take the variables that we've stored from asking the user to input two numbers, and you can add that to a string, or you can print those out. So the way that we do that is we use a semicolon, num1, semicolon, and I'm going and, because we want to see what the second number was that we entered, semicolon again, num2, 2, semicolon again, because we want to append another string, returned the answer of column, and then finally we want to show the answer, so we append answer. Okay, and hopefully that should all work. So final result here, don't forget to comment the code, print the answer to the screen. Okay. Screen, whoops. And then finally, if we come back to the algorithm, we should arrive at end. And if we look back at our code, that's exactly what it does. So you've now worked out that in every single application there is a main method. You know that we have to declare variables to hold data, and if it's numerical data, we're talking about integers and floats, doubles, bytes, and so on. If we need to store characters, and we store them in something called a string, a string of characters is a character array, and a character array is a pointer. So we can actually put some notes in here at the same time. Let's just do that. So first of all, every method, every application has a main method. Every application has variables, or containers if you like, in which to store data. Strings, you cannot store one type of data into another type of variable, unless it's the same type. You can, but I won't tell you. I'm not going to show you that just yet, unless it's the same type. Okay. Right. What else did we say? We said strings are arrays of characters. And what is meant by an array? Well, an array, to give you a very brief explanation, array of characters, I've just finished typing this, arrays of characters. An array is like a chest of drawers, and if we were to take hello, for example, hello would have H-E-L-L-O, would have 5 characters. So we would need 5 chests of drawers defined or dimensioned as characters, char, so that we could put each character into that drawer. That is an array. So an array is a collection of variables all put into one place, if you like. Well, not necessarily into one place, but if you could imagine it as something of a block divided into squares or cubes, then that is how an array would appear. Okay, so arrays are quite useful. You'll find out why later. For doing different types of data, or coding data, or working with data, they can be extremely useful. If we're going to use one whole string or a whole array of characters, then you'd use type string. Normally you'd use string when you have to type out a lot of characters and not an array. So we'll just leave it at that for the moment. And we said that strings are an array of characters, and an array is a pointer is a pointer in itself. Now, I'm not going to go too much into pointers, so I want you to just put that in the back of your mind at the moment, because we'll get to that later on. And that basically concludes this lesson. So let's run the program and see if it all works. First of all, let's just clear that. Let's make sure that we've got everything right there. So I'm going to put in, let's say, 25 for the first number. Second number, we're going to put in 35. And we should see a result of 60. So we know our program works to that point. But what happens, and this is, I'm going to leave this with you to think about, what happens if we decide to put in a decimal? Okay, so let's rerun the program and try and put a decimal in. So I'm going to put in 20.5, and for the second number I'm going to put, oops, didn't like that. Well. Why is that? Because it wanted an integer. The type mismatch wanted an integer. An integer is a whole number. So the only way I can change that to make that to work is convert that to float. Oops. Okay, just stop there for a minute. I'm going to have to convert that to float. Right. I'm going to float. Will store decimal numbers with a decimal point. Okay. And it has a maximum and a minimum value that you can store. Right. So it's more used for scientific calculations and for financial calculations. That's what you'd normally use a float or a double for. Okay, and we have to store the answer in a float. Right. So we have to do that as well. And what's the other problem? We have to convert, when we read that, we have to convert it back to a float. So we have to use CFloat. Yeah, and CFloat there. Okay. So now we've done that, now it will work. So let's just try that. Let's just go back, rerun the program, and now I can put in 20.5, enter, and it didn't fault, and I can put in 33.6, and it didn't fault, and now we've got the answer of 54.1. So you can see, if you don't define the memory, or dimension the memory correctly, that will throw an error. And it will still throw an error even though I've done that. And the reason for that is, if I decided to put 20.5 and put an ABC at the end of it, it's looking for characters. So it doesn't know what to do with the ABC, so it will throw an error. But we'll go into that discussion later. For now, I think that's quite a lot to take in. And if you've if you've managed to take all of that in, you've done extremely well. Well done. I will go back for, we'll be producing another lesson in part 3 and showing you how we begin to deal with some of that. I won't go into that straight away because that's quite involved too. So for now, you've got a simple program, or you can now write your first set of programs. Don't forget to use the word flash, by the way. Every time you use a print statement, remember to use the word flash afterwards. Otherwise, if you're looking for input from the user, it won't print that statement there. Okay, so flash is quite important. It's just the way that Gambas Basic deals with things. Thanks very much for watching. I just want to inform everybody that all of this has been done with open source. The presentation I put together was done with LibreOffice, Impress. The events and all the animation was done within LibreOffice. And I'm working on a pure open source operating system, Debian Linux version 12. I'd like to thank all of those who have sat and watched this. Bear in mind that some of us have to try and make a living on it, and any donations so that I can continue this work would be greatly appreciated, or any funding. Thank you, have a good day, and I hope you've learned a significant amount about your first introduction into programming. Thanks and cheers.